Hello, friends. I'm Kushal from Indeed Inspiring, and we are discussing conditional probability today. Let us start with the basic concept of probability. So, probability, by definition, is a branch of mathematics concerning numerical descriptions of how likely an event is to occur or how likely it is that a proposition is true. Let's take example. If you have two coins, so two coins have got head and tail. So these are the two possibilities we have. So we will call this as events. So how many events we have? The total number of possible events we have is two. Okay. Now, what is the possibility of getting one head? Getting one head possibility is 1 by 2. So 1 is the possibility of getting an head and total number of possibilities or events is 2. Similar way, possibility of getting tail is also 1 by 2. So here we can understand that the probability is ranging from 1 to 0 or vice versa, where 0 roughly indicates that it is impossible and 1 indicates that high chances of possibility. Let us move ahead and understand if you have two coins. With two coins, what are the possibility of events? So possible number of events would be head head, head tail, tail head, and tail tail. So now total number of events we have, it is equal to 4. And out of 4, if I want for head head, what is the probability? It is 1 by 4. Similar way for head tail or tail head, they both are the same things. So 2 by 4. So in probability, we consider head tail and tail head same. And tail tail, the possibility is 1 by 4. So these are the probabilities for head head, tail head, and tail tail. Okay, so if we have multiple such coins, so in that case, this is how the probability will be calculated. Now let us understand the concept of events. There are two types of events, dependent and independent. And now we will look at independent events first, that what exactly is independent event. So here you can have a look that two events are there. Okay, event 1 is there and event 2 is there. Okay, so event 1 takes place and then we see there are four possible chances. Okay, and after that event 2 takes place and then also there are four possible chances. So what is happening? The possibility of chances remains same. This might be a little confusing. So let me go ahead and explain you with an example that will make it very clear. Let's get back to the example of coins. So let's say you toss a coin for the first time, okay, and you get head head. Okay, so what was the probability of getting head head? The probability of getting head head was 1 by 2 because you have a single coin here. Okay, now second time if you toss the coin once again, what will be the probability of HH head head? It will be once again 1 by 2. So do you think will there be any possibility that once you toss a coin and second time the probability of getting head is getting reduced? It will never happen, right? It will never happen. So always the probability of getting head head or always the probability of getting head tail, okay, that will remain same. So let me make it 4 because I have written head head, so this means that there are two coins. Okay, yes. So the probability of events occurring, if it is getting changed because of the first event, then we will call it as dependent event. Otherwise, it is independent event. So let us go further and understand even dependent events. So here in the diagram, you can see that we have event 1 and then we have event 2. So in both the cases, you can see that in event 1, the possible chances were 4 and in event 2, the possible chances remain 3. So that means once event 1 has taken place, that is affecting the second event. So if this is happening, in this case, these kind of events will be called as dependent events. Let us understand with one example. So you can see that these boxes are called as marbles. They are the marbles, okay? And now, in case of these marbles, there are two types. One are blue marbles, other are red marbles. Now, what is the probability of getting blue marbles from this bag? So the probability is 2 by 5 because 5 is the total number of balls and 2 are blue balls. Okay, so only 2 times we will be able to pick up the blue balls. Okay, and rest of the 3 will belong to red one. Now, if you pick up a ball, okay, now next time what will happen? You have picked up a ball. So there are two cases. Either it will be a red ball or it will be a blue ball. Okay. So case one, if we see, so red ball was picked. Okay. Now what is the probability of getting blue ball? It became 2 by 4. Okay. In the second case, when blue ball was picked up, okay, then what is the probability of getting a blue ball? 1 by 4. So what is happening here if you see? 2 by 5, okay, probability of getting blue ball initially is 2 by 5, but after that event has taken place the probability has changed, okay, which was not the case with coins. Okay, even if we have 2 coins, 3 coins, 6 coins, the case will never change. The probability of getting head head or getting head 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 or getting tail head head will always remain same. Okay, because in this case the ball is basically taken out and ball has not come back. Okay, it's out of the box now. But in case of a coin, we cannot take HH head out of the coin. It is always there. Okay, you got why it is called as dependent, right? Let's move ahead. The same thing has been explained further. Okay, so here you can see in the next slide. So if you are taking the red ball, so 2 by 4 is the probability. And if you are taking the blue ball, 1 by 4 is the probability. And the reason is because we are removing the marbles, which was not possible in case of coins. We cannot remove head, right? Okay, let's move ahead and understand the concept of replacement. Okay, hope you are getting everything. Replacement means that whether you are replacing or whether you are just removing. So in case of balls, we just removed. In case of coin, it was replaced. Okay, so let's understand this with replacement. So this is a case of replacement. With replacement, events will become independent. Always they will become independent. You can see that case one, the first figure you see, okay, the probability of getting a blue ball, it is 2 by 5, correct? And whether you pick up the any ball, red or any, okay, so red ball is picked up. And when we started case 2, it was replaced. Okay, you can see the box is having all the balls back again. Okay, this is called as with replacement. Okay, now again the probability of getting blue is 2 by 5 only, it is not getting changed. Or probability of getting red is 3 by 5 only. Okay, why? Because we have kept the original box once again, and this is what we call it as we have replaced. Okay, so here we have one missing ball, so we are not using this, we are replacing it with the original ball, where original box where we have 2 blue balls and 3 red balls. This is what we have done. All right, so let's move ahead and understand. So here you can see in this example, so this is without replacement. So in case of without replacement, once the case one is done, okay, so one event has taken place and red ball is out. Now it is not replaced, the same box is being used. And in this case, the probability of getting red is 2 by 4 and probability of getting blue is 2 by 4. The probabilities has been changed and therefore it is called as dependent event. All right. So we will move ahead, okay, with further concepts of conditional probability in the next video, and that would be surely interesting. So keep watching